Good afternoon to all of you once again. In the previous presentation, I was talking about various algorithm solving strategies. So we have already learned in the earlier slide, that means in the earlier video, that the commonly used strategies that are used in algorithms are brute force, greedy approach, dynamic programming, and divide and conquer. So in this particular video, the objective will be to learn about each of these approaches in a little more detail. So first of all, let us understand what is brute force. Brute force means not using any intelligence or not using any proper strategy. Okay. So suppose you have been asked to open a box. So without finding how the box is supposed to be opened, you use your physical strength and smashed it open. So that is, although it is a straightforward approach, it is not obviously not the most intelligent approach and definitely not at all efficient. So brute force is the least efficient approach. You can see here there is an example. Suppose you have been given a lock with 4 digits, okay, which can go from 0000 to all the way up to 9999. So you have been asked to find the right combination that can be used to open that type of lock. So if you have no idea what the digits might be, if you have no way to know what those digits could be, you have to follow the most basic approach, which involves trying each and every combination of numbers until and unless you find the right one. Okay, so it is a very simple approach. Everybody can follow this approach, but it is very slow, very time consuming, and obviously very inefficient, especially when the range of numbers is very large. Trying each of those numbers will be a very painful process and a very cumbersome process. Next, we come to the greedy approach. Greedy approach means using whatever lies in front of you without actually evaluating or taking into consideration that the object that I am taking is, whether the object that I am taking is the right one or not. Am I selecting the right tool for the job? Or if I had adopted a more subtle strategy, a more intelligent strategy, whether I could have had a better outcome or not. So here you can see there is an example problem, that is, I have to make a change of 36 cents using the fewest number of coins, and I have been given coin denominations of 25, 10 cents, 5 cents and 1 cent. So we are, first of all, we are having in front of us 25 cents. So greedy approach will pick the 25 cent coins. So out of that 36 cents, only 11 cents is remaining. So now we are going to take 10 cents. So now 1 cent is remaining, and then for the 1 cent we are going to take the 1 cent coin. So by following this approach we have come at a solution, but in all situations it may not be the most efficient. Okay. So greedy approach, you are just greedily taking whatever you are getting in front of you without actually thinking whether that choice is the proper one or not. Maybe if you had selected a different item, you could have had a better and a more efficient outcome. Okay. Okay, now let us study the third problem, that is dynamic programming. Dynamic programming means creating a set of sub-problems and then using the results of those sub-problems to solve a larger problem. So here you can see there the example problem states that find the number of ways to climb a staircase of n steps where we can take either 1 or 2 steps at a time. So what is the DP approach? That means the dynamic programming approach. Break the problem into sub-problems. Okay. Example ways to reach n-1 and n-2. store the results of the previous steps to avoid recomputation. So as I have told you before, here we store the previously calculated values in a table so that we can reuse them later, and then when we are trying to solve the larger problem, we use the results of our previous calculation to solve overlapping sub-problems which are a part of the larger problem. That way we don't have to calculate the values of the smaller sub-problems again. Now the fourth one, which is the focus of today's video, is divide and conquer. So we have to divide and conquer means dividing a larger problem into smaller sub-problems and solving them until we arrive at the desired results. So here we are sorting an unsorted array of numbers. So if I follow the divide and conquer strategy, say merge sort, so we'll divide the array into two halves, then recursively sort each half, then merge each of the sorted halves to produce the final sorted array. So in this way we are breaking it into smaller parts and then combining the results of each part to create the final sorted array. So these are the strategies of commonly used strategies in algorithms. So this concludes this video, and in the next video I'll explore how divide and conquer differs from the linear problem solving approach. So thank you, and I'll see you in the next video.